Okay, very good afternoon, everyone. Um, I welcome you all to Podo Bharat Digital YouTube channel, my channel actually. Okay, uh, in the session one of that machine learning 2 subject. Okay, my today's important topic is ADA Boost. Okay, I going to deliver about this particular concept in detail and for examination perspective it is very much important. Okay, and in this particular concept we are going to discuss about what is ADA boost and the use of the ADA boost. Okay, I thought it will helpful for your um, for you in your examination. uh, I hope you all are on the board. Let me get into this and analyze in detail, right? See, what is ADA boost? ADA boost is nothing but adaptive boosting. Okay, abbreviation what is saying, adaptive boosting. The word in this particular title, what I'm focusing here, that word we have, boosting. What is boosting? Let me know that generally. What is boosting? Boosting is nothing but improving, increasing whatever the performance of the task, whatever the performance of the action. I hope so, right? That is called as a boosting, sir. Let me take this particular definition into your ADA boost, right? See, this ADA boost technique is there na, which is very important uh, for your ensemble learning technique, because we have seen already that what are the types of ensemble learning, isn't it? There are the three types in your ensemble learning. The first type is that is boosting. Okay, and the second one is bagging, and third one is bending. Okay, so these all are the your types of ensemble learning. So what happened, the boosting technique we already known in your physical class, but this particular boosting and ADA boosting having a little bit difference, sir. Okay, it means there is an important factor with respect to that ADA boosting in your ensemble learning. Getting? So that important factor here is weight. Okay, the weight is an important factor in your ADA boosting. Other than this one, in your boosting technique as well as in your ADA boosting technique, the similar factor is, sir, both are sequential. Both are sequential. Okay, you can see both are sequential ensemble model. I hope you are getting this one. What I'm saying, that sequential ensemble model means what? Let me define this first one, sequential ensemble model. So sequential ensemble model means, see, this is in a one diagram we have currently. What the diagram consists, there are the four important components. Training data set is there, model is there, error is there. We notified that one using the notation called E, and alpha is there. It is nothing but that notation I'm saying. Let me explain that each step one by one. So training data set, which consists the similar and dissimilar data, always. The model which is going to use in your machine learning for learning concept. Okay, after learning you will get the prediction. If there is an error in your prediction, if there is a mismatching in your final result, that's called as an error, sir. We also called as a bias. Okay, then to overcome this bias we use this alpha. Alpha is nothing but hyperparameter. We can say that we have already seen your regression in the classification class. Okay, so this is the general model, general machine learning model works. Okay, if I go through in depth of this general model explanation, you will understand the proper way of that working procedure within the machine learning. See what happened, always this training data set need to be learned. That is the first case. So the training data set learned by the appropriate model. The model is very important factor here, because always every model consists algorithm, or every model wants a algorithm. Okay, that model and appropriate algorithm help us to train the data which is already available in our data set. That model, after training the data set, will predict the output. That's we call as a prediction. If that prediction is accurate, no problem. What if not? Then the problem occurs. What is the problem here? Error. In our machine learning terminology, we call as a bias. There is a high bias and the low bias. It means there is a huge error in your expectation, or there is a minor error in your expectation. So I want to reduce that errors or a bias. Okay, to reduce that error or a bias, we need some important tuning technique. Okay, tuning technique. Tuning is nothing but adjusting. What I am adjusting? I am adjusting my particular error with respect to result. So that adjustment takes place by using the appropriate factor called as a hyperparameters. Alpha, beta, gamma are the hyperparameters, but especially here I am using the alpha. Alpha, there is the standard deviation value. Either it may be a beta, it may be a gamma. There will be a standard deviation value. If you apply those standard deviation values in your appropriate model tuning, then you will get the prediction as you expected. There is no problem, sir. This is called as a machine learning model. But here in your ensemble learning, that concept called AdaBoost concept, the factor very importantly affecting in your particular concept, that is alpha. It is nothing but, in this particular case, weight. Okay, so weights are the hyperparameters in your particular ensemble learning technique, especially in the AdaBoosting. So what happens usually? See, there is a concept here. You will get that prediction here, output here. After processing all the steps, you will get the prediction here. This prediction, say we are getting 50 out of 100 accuracy. Okay, then what I do, I want to get 95 out of 100. I want to get actually 95 out of 100, but what I get here, 50 out of 100 now. So how can I make it 50 to 95? Okay, see, the first iteration, okay, entire first iteration I got only 50. Let me take this value, okay, this value into your second iteration. Okay, so the second iteration, after updating this particular value, you will get the one more value, that is alpha 2. In this alpha 2, your 50% has been increased to the 70% due to some tuning. Okay, due to some tuning, it has increased into 70%, but still I want 95. Take this alpha 2 into third iteration. The third iteration will give that result 95 what you expected. So what happened, sir? The previous whatever the output I am using into the new classification. If I do this iteration combinedly, that process is called as an ensemble learning. I hope you are getting this. If I use those previous previous iteration outputs into the new task, into the new action, that process is called as an ensemble learning. Then later add these all, take the average of these all the values, alpha 1, alpha 2, alpha 3, that's we call as an overall prediction. That is the motto of your ensemble learning using the ADA boost. I hope you are getting, sir. No problem at all. Let me go into the this particular diagram using the number of iterations. See, we have, so what happens, sir? Data set already we have, no problem. Sample 1 is there. I will explain about the sample 1, why we got this here. And decision stump is the appropriate model or a classifier. And error 1 is there, the first prediction, or there is an error, there is an misclassification in your prediction, and this is called as updated weight. Okay, this is the first iteration, sir. This is the second iteration, sir. This is a n number of iterations, sir. Add these all the iteration, you will get the overall prediction, that is called as a HF. Now come to the what is sample 1. Sample 1 is called as a bootstrap sample. Bootstrap sample. What it means, sir? Bootstrap sample means, bootstrap sample is nothing but, for example, there is a data set we have. In this data set, please assume that there are the two values, 1, 2, 3. So bootstrap sample says it's a random selection with replacement. What the definition of bootstrap samples? Random selection with replacement. So the first bootstrap sample S1 consists 1 and the 2 are the instances. So these are randomly selected, and there is any replacement, then you need to provide it back again and go for the second bootstrap sample. That bootstrap sample consists 2 and 3. Okay, the 1 I replaced into the data set again. So this is the second random selection, 2 and 3, and put it back into your training data set and select the third bootstrap sample. The third bootstrap sample is 1 and 3. Okay, I replaced 2 into your original data set, 1 and 3. So there is a random selection and the replacement. So these are the 1 and 2, 2 and 3, 1 and 3 are the bootstrap samples. I hope you are getting this. These bootstrap samples need to be trained. Why I am using these bootstrap samples? The question obviously arises in your mind, why I am using the bootstrap samples, sir? Because this particular data set consists the similar and dissimilar data. There are the few similar, few dissimilar data sets, or else you can say that there are the few labeled or unlabeled data sets. If it is a label, the model easily detect that one, the model easily understand that one. If it is unlabeled, the model takes too much time, and the prediction what you get from the unlabeled might have a chances to inaccuracy. That is the main factor. So all the unlabeled data cannot be labeled because it takes too much time, it is it takes too much cost. Due to that reason only we use the alternate technique called as a bootstrap samples, that is in a random selection with replacement. Okay, after taking these all the bootstrap samples, you need appropriate classifier or that appropriate model. Here in this particular ensemble learning we have seen lot of the classifiers. For example, it may be a decision tree, it may be a neural network, okay, it may be a regression classification, but here I am using the decision stump. What is the importance of the decision stump? Decision stump says always the depth of the tree should be 1. It means the length of the tree should be 1. What it means? The length of the tree, there must be a one root node having a 2 children, having a 2 limbs. Okay, this is called as a depth 1. So that is the important factor of the decision. I noted that one using the H. Okay, so this is the main concept, sir. I hope you are getting this. Instead of one model, I am using the number of models. Why? Because the concept name is ADA boosting. See, after your decision tree with your bootstrap sample, you will get whatever some prediction here. That prediction is not up to my expectation. Okay, so that's why what I need to do, I improve this particular prediction value. How can I improve that prediction value? Apply the weight. Weight is in a hyperparameter. Why I am using the weight? I can adjust my result through the tuning. That is the most important factor. So these weight will give the one more weight called as an updated weight. What is the use of this updated weight? I can use this updated weight into the second iteration. Please follow the diagram. Here he is using the updated weight into bootstrap sample 2. Again using the decision stump classifier. Again you will get the updated weight. Again we are going to use into the sample 3. So iteration 1, the output of the iteration 1 are going to use in the sample 2, and the output of the iteration 2 going to use in the input of the 3. So this is the way the process usually exists. Through this way we can easily get the overall prediction. What happened here? This value boosting into this value boosting into this value, and this value boosting into the final value. If I add this one, you will get the one value, the overall boosting value, right? So this is the normal concept in your ensemble learning techniques, sir. We have that suitable we have algorithm for this one. See the algorithm. What it's saying: assign the uniform weight, so 1 by n to all the data instances. Means here the initial weights need to be taken. The initial weights taken through that probability instances or a probability concept. It means if you have in your data set there is a 10 number of instances, the probability of 10 instances will be 1 by 10. So apply this 1 by 10 to all the instances available in your data set. If there is a 10 instances, means apply 1 by 10, 2 into 1 by 10, 3 into 1 by 10, like this way you need to apply. That is called the initial weights, which are uniform. Second step is there, train a weak classifier. So in this particular diagram, these all are the these all are the are the weak classifiers. Okay, these all are the weak classifiers. So one weak classifier could not able to produce the proper result. That's why I am using the number of weak classifiers to get the overall result. Okay, so that is the concept here. And compute the weight of error. It means he is saying that you need to find the weight of this error. So to find the weight of this error, we have a formula. See, this is the formula. So what happens here? See, normalizing factor Z is there. You need to find the normalizing factor here. Yes, the normalizing factor is there. That is the correct instances plus incorrect instances need to be added here. And the final one is, this is the final output. The overall prediction need to be taken here only. That is the formula we have, appropriate formula. That step is compute the final perfection value. Okay, I hope you are getting this particular algorithm. See, this is important for your examination perspective. In the next session I will be within your new topic. Until then, goodbye, thank you.